Hello kids, welcome to Learner's Planet. Kids, this is our fourth session for factors and multiples. In our previous sessions, we have discussed about prime numbers, composite numbers, factors, multiples, and we have already discussed divisibility rules of some numbers. Okay, in this session, we'll be discussing some more concepts. So let's begin this session. Kids, let's discuss a new term that is co-prime numbers. We have already discussed about prime numbers. Now what were prime numbers? Prime numbers are the numbers which are having exactly two factors, that is number 1 and the number itself. Say 2, 3, 5, 7, all of these are prime numbers since they don't have any other factor except 1 and the number itself. Okay. Now let's learn this term co-prime numbers. Here, two numbers not necessarily prime are co-prime if they have only one as common factor. Okay. Here are some examples: 1 2, 1 3, 3 4, 3 10, 3 8, 5 6, 7 8, etc. These numbers are called as relatively prime numbers. Kids, what are co-prime numbers? This is a definition I have mentioned over here. Just take 2-3 more examples. Suppose I have a pair of numbers 2 and 5. Okay. 2 and 5, both of them are prime numbers. Also, they are co-prime since they don't have any other common factor except 1. Okay. What are the factors of 2? It's 1 and 2. Just write over here. And what are the factors of 5? It is 1 and 5. So you can see there is only one common factor, that is 1. Okay, so 2 and 5 are co-prime numbers, or we can say they are relatively prime numbers. Now let's take 1 or 2 more examples. Suppose I have numbers 8 and 9. Now I list down the factors of 8. They are 1, 2, 4 and 8. And now I write down the factors of 9. So it's 1, 3 and 9. Now we can see that there is only one common factor, that is 1 is factor of 8 also and 1 is factor of 9 also. No other number is factor of 8 and 9 which is common. Okay, so it's only one common factor, that is 1. That's why 8 and 9 are co-prime numbers, or we can say relatively prime numbers. Okay, kids, it is not necessary that two numbers are co-prime only if they are prime. In this case, 8 and 9 individually they are not prime numbers, but as a pair they are co-prime numbers. And why they are co-prime numbers? They have only one common factor, that is number 1. Let's take one more example. Suppose I have numbers 14 and 15. Now I just write down the factors of 14. It's 1, 2, 7 and 14. Okay, now I just write down the factors of 15. It's 1, 3, 5 and 15. Further we can see that there is only one common factor between these two, that is number 1. So further 14 and 15 also have only one common factor, that is number 1. So even 14 and 15 are co-prime numbers. So whenever two numbers are having only one as a common factor, they are known to be co-prime numbers, or we can say relatively prime numbers. Now we can draw one more conclusion over here, that the continuous number, that means two consecutive numbers are always co-prime. Okay, isn't it? See, we can see 7, 8, 5, 6, 2, 3, 3, 4. All of these are co-prime numbers. Okay. So whenever you see a pair of consecutive numbers, you just can say that these are co-prime numbers. Okay. Now let's understand one more term. Kids, before we learn new term, we should keep these 2 points in our mind. These points are very important. Two distinct prime numbers are always co-prime, but converse need not to be true. Two distinct prime numbers are always co-prime. That means if two numbers are prime, then their pair will be a set of co-prime numbers. We can say 2, 3, we can say 2, 5, we can say 5, 7, 11, 13. Okay, so all of these are prime numbers. That means the pair of them will be co-prime. Okay, and similarly consecutive numbers are always co-prime numbers, as we have already taken examples 7, 8, 9, 10, 11, 12, 13, 14. Okay, it is not necessary that both the numbers in this set is prime, but since they are consecutive, they won't have any other factor as common except number 1. Okay, so these are also co-prime numbers. In this case also 9 is not prime number, 10 is not prime number, but it is a set of co-prime numbers. Okay, so I hope you are clear with the definition of co-prime numbers. Now let's learn what are twin prime numbers. Now let's see what is twin prime numbers. If the difference between two prime numbers is 2, then the numbers are called twin prime numbers. Okay. For example, 3, 5, 5, 7, 11, 13, 17, 19, 29, 31. Kids, in this case, both the numbers should be prime. Okay, and if the difference between these two prime numbers is 2, then we call them twin prime numbers. Here 3, 5, both of them are prime numbers, and the difference between these two prime numbers is 2. So 3 and 5 is known as a set of twin prime numbers. Okay, or we can say even 5 and 7, the difference between these two prime numbers is 2. So these are called twin prime numbers. Okay. Similarly 11, 13, 17, 19, 29, 31. In all of these cases, both the numbers are prime numbers and the difference between them is 2. Okay. So I hope you are clear with the definition of co-prime numbers and twin prime numbers. So do not get confused. Now we'll be taking some questions and problems. Kids, now it is time to solve some problems. We have already discussed how to find whether a number is prime or composite. Now let's take some practical problems. I have already given a chart over here in which the counting from 1 to 100 is written. Now the very first question is, what is the smallest prime number? Kids, you know that which is the smallest prime number? The series of prime number begins with number 2. Okay, and what about 1? 1 is neither prime nor composite. So 1 is the only number which is neither prime nor composite, and the series of prime numbers begins with 2. So the smallest prime number is number 2. Okay, so it's number 2. Okay, now let's take the next question. Now the second question, how many prime numbers are there from 1 to 100? Kids, we have already done an activity in our previous session. So you can revise that session. I'm just writing down the answer over here. There are total 25 prime numbers from 1 to 100. And even I'm marking the prime numbers over here is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So we can count how many prime numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25 prime numbers are there from 1 to 100. Okay, and you can revise the activity, that how we are calculating whether this number is prime number or not. Okay, now let's take the next question. Now the next question is, which is the smallest composite number? Kids, let's see over here. 1 is neither prime nor composite. 2 is the first prime number. Okay, 3 is the prime number. So the smallest composite number is number 4. Okay, 1 is neither prime nor composite, and 2 and 3 both of them are prime numbers, and the smallest composite number is number 4. Okay, let's take the next question. Now give an example of even prime number. Kids, in the entire series of prime number, there is only one even prime number, that is number 2. Okay, so there is only one example of even prime number, that is number 2. Okay, all other prime numbers are odd numbers. You should always be clear about it, that there is only single even prime number, that is number 2 in the series of prime numbers. All the remaining prime numbers are odd primes. Now the next question is, how many even prime numbers are there? In the previous question we have already discussed that in the series of prime numbers there is only one prime number which is even, and that is number 2. Except 2, all the prime numbers are odd numbers. Okay, so how many even prime numbers are there? It's 1 only. And what it is? It is number 2. Okay. Now the next question is, how many one-digit prime numbers are there? Kids, whenever we have to find out prime numbers, the very first step is we just cross all the multiples of 2, 3, 5 and 7. Okay, and leave 1 as it is. So I'm just not including 1. I'm crossing, I'm not taking this 1. Let's cancel it. Now cross the multiple of 2. It's 4, 6, 8 and 10. Okay, now cross the multiple of 3. Cross or circle whatever. So it's 6 is already there. Now it's 9. Then cross or circle the multiple of 5. We have already done that. Now cross the multiple of 7. It's not there. So now we are left with the prime numbers. So we are left with 2, 3, 5 and 7 which are having single digit, and these are prime numbers. So how many one digit prime numbers are there? These are 2, 3, 5, 7 and in all there are 4 one digit prime numbers. Okay.